During the production of Jurassic Park, only a handful of Tyrannosaurus rex skeletons, around 7 or 8, were known to exist worldwide. However, the subsequent years have brought significant advancements in paleontology. As researchers uncovered more specimens, their understanding of this iconic dinosaur has evolved dramatically. This increased number of discoveries has not only enriched the scientific community's knowledge, but also captured the public's imagination, leading to a deeper interest in this prehistoric giant. T-Rex fossils showed that they were much different than our cinematic depictions. By 2019, paleontologists had unearthed over a dozen more complete T-Rex skeletons from various locations globally. These new findings enabled scientists to revise and refine their understanding of the T-Rex. The additional data gleaned from these skeletons led to some surprising revelations about the appearance and behavior of this apex predator. These discoveries have been instrumental in painting a more accurate picture of the T-Rex, challenging and changing many of the long-held perceptions about this dinosaur. One of the most intriguing revelations about the T-Rex is its unique physical appearance, debunking the traditional portrayal of a purely scaly predator. Researchers uncovered that T-Rex possibly sported a distinctive pattern of feathers, akin to the modern concept of a mullet hairstyle. This finding suggested that the fearsome dinosaur may have had a softer, more avian-like appearance than previously thought, altering the way we visualize these ancient creatures. Scientists hypothesized that the T-Rex, like other tyrannosaurids, likely had feathered adornments. These feathers would have run from the top of their heads along their spines, culminating in a tufted flourish at their tail ends. This feathered feature would not only have been a visually striking characteristic, but also might have played a role in temperature regulation or mating displays, offering a glimpse into the behavioral aspects of these formidable dinosaurs. The notion of feathered T-Rex remains speculative, as direct fossil evidence of feathers on T-Rex remains is scarce. However, the discovery of feathered relatives within the Tyrannosaur family tree suggests that feathers might have been a common trait among these theropods. This inference is based on the principle that evolutionary traits often appear across related species, making the feathered T-Rex a plausible scenario. The concept of a feathered T-Rex challenges traditional images of this dinosaur as a purely menacing predator. Instead, the idea introduces a more nuanced view of its life stages. Paleontologists believe that T-Rex hatchlings might have been covered in a fine, downy layer of feathers, lending them an unexpectedly gentle appearance in contrast to their adult form. Survival rates for T-Rex hatchlings were low, with only a small percentage making it to adulthood. Those that did survive shed most of their juvenile feathers, retaining only the distinctive mullet and tail feathers. This evolutionary journey from a feathered juvenile to a largely scaled adult highlights the complex life cycle and growth patterns of these ancient giants. Gregory Erickson, a renowned paleontologist from Florida State University, likened the T-Rex to the James Dean of dinosaurs. This analogy draws a parallel between the short, impactful lives of both the iconic actor and the T-Rex. James Dean's famous phrase "live fast, die young, leave a good-looking corpse" aptly encapsulates the fleeting yet impactful existence of the T-Rex in the Earth's history. The T-Rex's life, though relatively short by human standards, was filled with dramatic growth and change. Paleontologists used growth rings in dinosaur bones, similar to tree rings, to estimate their ages at death. Most T-Rex didn't live past 30 years, but their presence during that time left an indelible mark on their ecosystems and on our understanding of prehistoric life. The T-Rex's relatively brief lifespan was characterized by rapid growth and development. From their early days as feathered hatchlings to their final form as massive predators, T-Rex underwent a tremendous transformation in size and appearance. The average T-Rex would gain an astounding 1,700 pounds each year, reaching a maximum weight of around 9 tons. This rapid growth rate is a testament to the harsh and competitive environment in which they thrived, and it underscores the remarkable adaptability and resilience of these prehistoric titans. The T-Rex's short arms have long puzzled scientists and enthusiasts alike. Initially, they were thought to be vestigial, akin to human appendixes or wisdom teeth. These appendages were remnants from earlier Tyrannosaur ancestors, who managed just fine with minimal arm usage. Despite their underwhelming size, the arms were muscular and may have served purposes not entirely understood yet, such as aiding in hunting or mating rituals. Despite the limitations of its arms, the T-Rex compensated with its formidable jaws, a defining feature of this apex predator. Mark Norell from the American Museum of Natural History highlighted the T-Rex's unique ability to crush and digest solid bone. This ability wasn't just about strength, but also about the efficiency of their digestive system, which could process tough, nutrient-rich bone matter. The diet and digestive capabilities of the T-Rex have been further unraveled through the study of coprolites, or fossilized dinosaur feces. The existence of such fossilized remains provides an unusual yet insightful glimpse into the prehistoric diet. Chemical analyses of these coprolites have revealed fragments of bone, suggesting that the T-Rex consumed and digested bones, supporting the theory of their bone-crushing bite. The T-Rex's dental health was a marvel of prehistoric biology. Their teeth, massive and sharp, weren't permanent fixtures. Instead, these dinosaurs experienced continuous dental regeneration, losing and regrowing teeth approximately every 2 years. This constant cycle ensured they always had a set of powerful teeth at their disposal, crucial for their carnivorous lifestyle. This continuous tooth replacement played a crucial role in maintaining the T-Rex's status as an unrivaled predator. Their bite force, estimated at a staggering 7,800 pounds, was unmatched in the animal kingdom. Such power could pulverize prey, functioning like a natural hydraulic press, emphasizing the T-Rex's efficiency as a top predator. The debate about the T-Rex's hunting habits, whether it was a pure predator or a scavenger, has been ongoing. Recent studies, particularly those analyzing fossilized feces, suggest that cannibalism occurred among T-Rex. This evidence implies that they didn't just hunt live prey, but also consumed carcasses, including those of their own kind. Despite some theories suggesting scavenging behavior, most current evidence strongly supports the image of the T-Rex as an active and adept hunter. Contrary to the depiction in popular media like Steven Spielberg's Jurassic Park, T-Rex likely had excellent vision. Their forward-facing eyes provided them with sharp depth perception, a crucial trait for tracking and ambushing prey. The myth about T-Rex only seeing moving objects is just that, a myth. With their large eyes, comparable in size to oranges, T-Rex likely had excellent vision, crucial for a predator. This ocular advantage would have been essential for spotting prey from a distance, evaluating the environment, and effectively hunting in their prehistoric habitats. The idea that T-Rex could run at high speeds has been debunked by recent research. Their leg structure, similar to that of elephants, suggests they were built for power, not speed. They maintained at least 1 foot on the ground at all times, preventing them from true running, but enabling them to be effective speed walkers. As T-Rex hatchlings grew, their ability to run diminished, but this didn't hinder their hunting prowess. They evolved to become adept at walking quickly, covering ground efficiently with long strides. Estimates suggest they could move at speeds between 10 and 25 miles per hour, more than sufficient to ambush prey. This combination of strength, speed, and visual acuity made the T-Rex a dominant force in its ecosystem, feared by many contemporaries. The debate over the T-Rex's true colors remains a tantalizing mystery in paleontology. While movies typically depict them with muted earthy tones, this portrayal is based more on artistic license than scientific evidence. The possibility that T-Rex may have sported vibrant, colorful hides is a thrilling prospect. A discovery of preserved skin or pigment could revolutionize our understanding of these ancient creatures, adding a new dimension to our image of the prehistoric world. The search for evidence of dinosaurs is a complex endeavor. Paleontologists often scour areas where the remnants of ancient life might be preserved. Yet, what seems like ordinary, weathered rock formations can often conceal fossilized remains. The key is knowing where to look, understanding geological formations, and recognizing potential fossil beds that could hide these ancient secrets. Many significant paleontological discoveries have been made purely by accident, changing the lives of ordinary people like Juan de Dios Soto, an Argentinian farmer. His routine life was upended when he stumbled upon something extraordinary on his land, a chance finding that transformed his farm into a hub of scientific activity. drawing experts from around the world eager to study this unexpected discovery. Juan's discovery was as unexpected as it was transformative. On a day that began like any other, with Juan leading his cattle to graze, a drought had altered the landscape, revealing secrets previously hidden by nature. It was in these altered conditions, in the parched riverbeds of Valamanca, that Juan encountered a relic of the past. The Valamanca riverbeds, usually teeming with water, had dried up, leaving behind a cracked, barren landscape. As Juan navigated his herd through this unusual terrain, he inadvertently stumbled upon a peculiar object. Initially dismissing it as a mere rock, he soon realized that this was no ordinary stone, but something far more intriguing. Juan examined the strange rock, noticing its unique organic patterns. It bore the marks of something once living, a realization that sparked his curiosity and sense of responsibility. He understood this was a find significant enough to warrant expert attention and was determined to share his discovery. Local archaeologists quickly descended upon Juan's farm, eager to investigate the unusual find. Their excitement only grew when they discovered that the initial object wasn't alone. This revelation suggested that the area might have been home to multiple creatures from the same species or time period, further increasing the site's significance. The discovery of a second, significantly larger object near the initial find along the riverbank marked a turning point in the archaeological dig. This prompted the team to intensify their efforts, leading to a more comprehensive excavation of the area. The decision to expand the excavation site was driven by the tantalizing possibility of uncovering further artifacts or remnants of historical significance. As the team delved deeper, the sense of anticipation grew, fueled by the potential of unearthing elements that could redefine existing historical narratives. Each shovelful of earth brought them closer to new revelations, and the team worked tirelessly, their excitement palpable as they uncovered layers of history long buried beneath the surface. As the excavation progressed, the team unearthed an astonishing find. 4 large, shell-like objects, each revealing a unique story from an ancient past. Initially, these shells were thought to belong to a species similar to modern-day animals, perhaps akin to tortoises, given their size and distinctive shape. This hypothesis sparked a flurry of excitement among the archaeologists as they pondered the implications of such a discovery. However, as they studied the shells more closely, it became evident that they might be dealing with something far more intriguing than initially thought. The prospect of uncovering a new species or gaining insights into ancient fauna electrified the atmosphere at the dig site. Further examination of these mysterious objects led to a significant shift in the team's initial hypothesis. These were not the remains of tortoises, nor did they belong to any known animal of the recent past or present day. The unique size and structure of these casings hinted at a far more ancient origin, possibly belonging to creatures from a bygone era. This realization opened up a realm of possibilities, suggesting that the team might have stumbled upon a significant paleontological find. The prospect of discovering new species or understanding the evolutionary history of known species was both exhilarating and daunting as the team grappled with the potential implications of their find. The revelation that the shells belonged to glyptodons, ancient relatives of modern armadillos, was nothing short of astonishing for the research team. These prehistoric creatures, which roamed South America approximately 30 million years ago, presented a stark contrast to their smaller contemporary relatives. Glyptodons, unlike modern armadillos, were massive and imposing, with a physical presence far removed from the cute or cuddly image associated with their modern-day cousins. The discovery of these ancient remains provided a tangible connection to a distant past, offering a glimpse into a world vastly different from our own. The team's excitement was palpable as they realized the significance of their find in understanding the evolutionary journey of these unique creatures. The sheer size of the glyptodons captivated the imagination of the researchers. Standing at about 5 feet tall, stretching 11 feet in length, and weighing over 2 tons, these creatures were comparable in size to a Volkswagen Beetle. This comparison highlighted the enormity of the glyptodons, underscoring their status as one of the larger armored mammals of their time. The realization of their massive stature brought into sharp focus the radically different world they inhabited. The glyptodons were remarkable not just for their size, but also for their extensive armor. They possessed thick, bony shells, heavily armored heads, and tails that could serve as formidable weapons against predators. This natural armor was a testament to the harsh and predatory environment in which they lived. Despite their formidable defenses, the glyptodons were not invulnerable. They faced numerous threats in their era, from natural predators to environmental challenges. The study of their armor and its effectiveness in providing protection offered the researchers a unique window into the survival strategies of prehistoric creatures. The existence of glyptodons was marked by a constant struggle for survival. Their shells, once a bastion of safety, became a target for early human hunters, who exploited them for shelter and other uses. This human interaction played a significant role in their eventual extinction, which is believed to have occurred around the beginning of the Holocene epoch, approximately 10,000 years ago. The study of their extinction provided crucial insights into the interactions between early humans and megafauna, as well as the broader ecological impacts of human activity on species survival. The discovery made by Juan de Dios Soto was groundbreaking in many respects. Prior to this, glyptodon shells had only been found in isolation, never in a collective group. The unearthing of 4 glyptodons together in one location was a rare and significant event, enriching the fossil record and deepening our understanding of these ancient creatures. This find was not just a remarkable achievement in the field of paleontology, but also a testament to the unpredictability and richness of the archaeological record. It provided an unprecedented opportunity to study glyptodon social structures and behaviors, potentially offering new perspectives on their way of life. Archaeologist Pablo Messino was particularly intrigued by the orientation of the glyptodon fossils. The fact that most of them faced the same direction suggested a coordinated movement or behavior, hinting at social or migratory patterns previously unknown in glyptodons. This observation opened up new avenues of inquiry, challenging existing assumptions about the behavior of these prehistoric creatures. The possibility that glyptodons exhibited complex social behaviors or migratory tendencies was a tantalizing prospect, offering a new dimension to our understanding of these ancient giants. This aspect of the discovery underscored the ongoing mysteries of the past, continually fueling the curiosity and drive of researchers in the field. The uncovering of the glyptodon fossils opened a fascinating window into the potential social structures of these ancient creatures. The specific arrangement of the remains suggested a familial grouping, perhaps indicating the presence of parents and their offspring. This arrangement was not just a rare find, but also a provocative clue into the social dynamics and family behaviors of glyptodons. It hinted at a level of social organization and interaction previously unexplored in paleontological studies of this species. The possibility that glyptodons may have had complex social structures, including familial bonds or group living, was a revelation that excited the scientific community. This discovery promised to transform our understanding of glyptodons, not just as solitary giants of the prehistoric world, but as creatures with potentially intricate social lives. The discovery of shells varying in size sparked a new line of inquiry among researchers regarding sexual dimorphism in glyptodons. This variation led to the hypothesis that gender might have been a significant factor in determining the physical characteristics of these prehistoric creatures. The possibility that male and female glyptodons exhibited distinct differences in size or other physical traits opened up a new realm of study. Researchers speculated on the roles these differences may have played in their behavior, survival strategies, and mating rituals. Understanding sexual dimorphism in glyptodons could provide key insights into their reproductive strategies, social hierarchy, and even their evolutionary adaptations. Paleontologist Riccardo Bonini was particularly captivated by the unique nature of this discovery. The simultaneous finding of several glyptodons who appeared to have died under similar circumstances was extraordinarily rare and highly valuable for research. Bonini emphasized the wealth of information that could be gleaned from such a find, ranging from their diet and health to their social interactions and environmental conditions. The fact that these creatures were found together raised questions about their communal behaviors, environmental stresses, and the circumstances leading to their demise. This exceptional discovery had the potential to illuminate aspects of glyptodon life that had remained shrouded in mystery, providing a clearer picture of their existence in the prehistoric ecosystem. The task of excavating the glyptodon remains presented significant logistical challenges due to the enormous weight and fragility of the 1,000-pound shells. The archaeological team had to meticulously plan every step of the extraction process. Specialized equipment and techniques were required to ensure the safe and intact removal of these ancient relics. The process demanded not just physical effort, but also a strategic approach to preserve the integrity. Upon their arrival at the Incuapa research facility, the glyptodons were set for a comprehensive series of analyses. Researchers were particularly eager to conduct DNA testing and other advanced examinations. These tests aimed to determine the sex of the individuals, estimate their age, and identify the causes of their death. Such information was crucial for constructing a detailed understanding of their biology, behavior, and the environmental conditions they lived in. The analysis promised to yield vital clues about their diet, genetic diversity, and potential diseases, contributing significantly to the broader understanding of glyptodon life and the prehistoric era they inhabited. For Juan de Dios Soto, the man whose accidental discovery brought these prehistoric wonders to light, the experience was one of immense pride and wonder. His unexpected encounter with the glyptodons, along with another significant nearby find, had a profound impact on the scientific community's knowledge of these ancient creatures. Soto's role in unearthing these relics highlighted the contributions of ordinary individuals to scientific discovery. His discovery not only enriched the world's understanding of glyptodons, but also added depth to the narrative of Earth's distant past. This momentous occasion stood as a testament to the unpredictable and exciting nature of archaeological exploration. Thanks for watching, and don't forget to like and subscribe.